All right, welcome to another episode of How Do We Pass Our Common Core Algebra Regions. Now, we are about to, on the previous episode, we already solving regions problems. The problem is that, wow, I just said two words. Okay, the issue here is that the next topic is called regressions. Regressions are equations of functions, okay? So in order for us to do that, I need to make sure that you guys are fluent in graphing linear, quadratic, and exponential functions. So let's start with the linear ones, okay? Straightforward. We have a table of values, we got the graph, and we graph, okay? So let's see. Let's say we have the equation y equals 2x plus 3, okay? So I made this table. You won't have this type of table on the regions. You might have to construct a table. It's always a good idea. Remember, the calculator can always help you with that. But let's do it by hand right now, and then we're gonna explore certain aspects of the linear equation. So right now we're just gonna graph it. So this is gonna be called the machine, whatever we do to the machine. So y equals 2 times the value of x plus 3. If I'm going too fast, then you're gonna have to rewind it. Alright, now the x values are independent. We could give as many values as we want to. Usually I pick negative values and positive values because in my graph I want to cover the negative side and the positive side of the x. This is the x-axis, okay? Positive side, negative side. Y-axis, positive side, negative side. Let's complete our table of values by hand. Later on you could just do it with the calculator. So I'm gonna start at -3, then go to -2, -1, 0, 1, 2, 3. Are these always the values that I'm gonna be giving? No. You give values according to what you think you should graph. So now what do I have here? Well, 2 times the value of x. The value of x in this case is -3 plus 3. See that? I have not calculated anything. Again, 2 is already there. You see, it's always there. So it's 2 times the value of x, which in this case is -2 plus 3. 2 times -1 plus 3. 2 times 0 plus 3. 2 times 1 plus 3. 2 times 2 plus 3. 2 times 3 plus 3. Okay? And now we're going to calculate those values. So let's do it. 2 times -3 is -6. -6 plus 3 is -3. Okay. 2 times -2 is -4. -4 plus 3, -4 plus 3, -1. 2 times -1 is -2. -2 plus 3, 1. Now listen, I'm doing it fast, but you should, after you have the table of values, you should pause it and do it yourself to see if you are fluent in it. Because the better you do it, the faster you could skip this video. So 2 times 0 is 0 plus 3, 3. 2 times 1 is 2 plus 3, 5. And the next one is going to be 7, and the next one is going to be 9. How do I know that? I saw a pattern happening here. Okay. And it's true, look, 2 times 3 is 6 plus 3 is 9. Okay, now here's where you put the order pairs, all right? You create this table yourself. So x comma y, that means that you're gonna put the values of x and the values of y. So -3 comma -3. -2, -1, 0, 1, 2, 3. Because are all the values of x, right? And then the values of y. So -1, 1, 3, 5, 7, and 9. You see? So these are called order pairs. These are coordinates. Just in case, I'm assuming that you don't know anything, right? So these are coordinates. And now I'm going to put these coordinates into the coordinate plane. So let's see. The first one was -3 comma -3. Correct? Look. -3 comma -3. So that's exactly what I'm gonna graph. I'm gonna go to -3. So these are the negatives on the x. So this would be, this is what we call the origin, 0, 0. Okay, now you might want to put numbers on your coordinate plane. I already know that it's numbered. There are 10 units here, 10 units here, 10 units here, 10 units here. So these are the negative units, so -3. So I move -3 units. Actually, I move 3 units to the left. And then for the y, I'm gonna move 3 units down. 1, 2, 3. And this, my friends, is -3, -3. Let me go on to -2, -1. So I go to the origin, that's where my starting point, and -1, -2, and now for the y's is -1. So this is the point, -2, -1. My next point is -1, -1. -1 for x and 1 for the y. My next point is 0, 3. 0 for x and 3 for y. Okay, my next point is 1, 5. 1, 5. My next point is 2, 7. And my next point is 3, 9. Becca, how you doing it so fast? Nah, I'm just kidding. I saw a pattern. Okay, look, the graph is from one point to the next is going 2 up and 1 to the right, 2 up, 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 1 to the right. So basically that's what I followed. See, yeah, you thought I was a genius. So now I connect the graph. Yeah, you thought right. And this, my friends, is the graph of your equation, of your function, y equals 2x plus 3. So that's exactly what I'm gonna call it. Every time you do something, you gotta label it. So y equals 2x plus 3. Oh, okay. So now on the other one, let's graph a different equation. Okay, if you need to see this or pause it, then you can pause it. Let's graph, I don't know, y equals 1/2 of x, I don't know, minus 2. Let's just do that, okay? Then we are going to, I'm going to explain to you something else, okay? So let's do this. All right, so what do I know about this? That in this little column, I'm going to have 1/2 1/2 of x minus 2. So what kind of value should I give? Well, half of 2. That means that every value that I give, I'm going to be dividing by 2. I'm going to try negative 4, -3, and then this is the only value I'm going to try here. Then, oh, you know what? No, I'll try -2, and then I'm going to skip from -2 to 0. I'm going to skip from 0 to 2. I'm going to skip from 2 to 4. But Bex, why are you doing that? Well, it all makes sense once we get our values. So anyway, so let's see. Half of -4, right? Minus 2. Half of -3 minus 2. Half of -2 minus 2. Half of 0 minus 2. Half of 2 minus 2. Half of 4 minus 2. So let's see what's going on. What is half of -4? Half of -4 is -2. -2 minus 2 is -4. Okay. Half of -3 is -1.5. -1.5 minus 2 is -3.5. Half of -2 is -1. -1 minus 2 is -3. Half of 0 is 0. Minus 2 is -2. Half of 2 is 1. Minus 2, -1. Half of 4 is 2. Minus 2 is 2. Let me give you another value, 6. Half of 6 is 3. Minus 2 is 1. Something is not right. Let's go back here. Half of 4 is 2. Minus 2 is 0. Okay, sorry. 0. Okay. So now, what do you notice about all these values? You could pause it and then think about it. Look, when I gave even numbers for my x, I got nice values, whole numbers, right? Integers. But when I give an odd number, I get a decimal. And that's why I only get one odd number. Well, this number is multiplying x. This is the number that changes x. So it's gonna change it by a half. Whatever x is, you gotta take a half. So if this was a 5, we have to take half of 5, which is 2.5. You see, a half means to divide by 2. So every value that I give here was gonna get divided by 2. So that's why I chose even numbers. If this had been 1/3, that means that everything will be divided by 3. So I would have just given numbers that are divisible by 3. I would have started at -9, -6, -3, 0, 3, 6, 9. I hope you understand that much. All right, so let's graph this. Oh, by the way, I am not going to graph that 3, 3.5, and I'm going to explain to you again why. I hope this video will be the best, one of the best videos. So let's start with -4, -4. -1, 2, 3, 4, -1, 2, 3, 4. -2, -3. -2, -1, 2, 3. Okay? Then 0, -2. 0, -2. Then, okay, then 2, -1. Okay, 2, -1. Then 4, 0. Then 6, 1. I'm a genius. No, again, I saw the pattern. Okay, and then you have to graph your line. Alright, so I'm going to stop right here. I graphed 2 of this, one with a whole number and one with a fraction. I'm going to stop right here because now we need to go into what it really means, the meaning of this equation. So, taking notes, when you graph a linear equation, okay, the equation must be in the form of y equals mx plus b, or y equals ax plus b. Now look, however you call this letter that is multiplying the x, it doesn't matter. So let's go with the letter m, but it could also use the letter a. The letter m represents the slope of your line. Okay? The letter b represents your y-intercept. Okay? Now, this y-intercept is the point where your line crosses the y-axis. Okay? The y-intercept point, okay, point where line or where graph touches y-axis. All right, so far so good. So every time you are going to graph a line, the line has to look like y equals. Later on, we're not going to use y. Later on, we're going to use the following. F of x equals to ax plus b. F of x and y mean the same thing. They are interchangeable. So, what else? Well, that instead of creating a whole table of values for each equation, we could look at the form and see what's going on here. So, for example, let us write the form right here. Y equals mx plus b. Let us write it over here. Y equals mx plus b. Now, I could say plus, but in reality, it could be plus or minus b. Okay? So, my question is the following. Is this equation in the form of y equals mx? You see mx, m is any number, but it's still the slope. Mx plus b. B is just a regular number. Okay? So, let's go back down. The coordinates of the y-intercept. Okay? Coordinates of the y-intercept are always 0, comma, whatever the y-intercept is. Alright? Those are the coordinates. In the slope, when we graph, not on the equation, but when we graph, should be in the form of a fraction. What does that mean? Okay? When graphing, equals a fraction, even if it's not. Alright, right now it doesn't make any sense. Now let's make sense of it. After we wrote all this information, have this handy, please. Make sure you take notes. Okay, so the slope. The slope is the rate of change, is how much the x is changing. So in this case, the x is getting doubled. So the slope of this line is 2. So I'm going to write it over here. The slope of this line is 2. Okay? Now when I say, what I said before was that when we look at the graph, or when we're graphing, the slope should be a fraction. So how do I turn 2 into a fraction? 2 over 1. Alright. And the coordinates of the y-intercept right here should be, well, what are the coordinates of the y-intercept? 0, comma b. The y-intercept, it's this, a loose number. So it's 3. So the coordinates of the y-intercept are 0, comma 3. Yeah, but how does this help me? How having a slope of 2 over 1 and a y-intercept of 0, comma 3 help me identify the graph? Well, let's analyze this graph. How do you get from one point to the next one? Correct. You saw it, right? Any point that you choose, you will go 2 units up and 1 to the right. 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 So it does work. A slope of 2 over 1 determines the behavior of the graph. Yes, but how do I know where to start? Well, that's the beautiful part. That from the equation you can also determine the y-intercept. In this case it was 3. So definitely I will start at coordinate 0, comma 3. Let's see if it's true. 0, comma 1, 2, 3. No way. Exactly. So in the future, and that works for every linear equation. Okay, remember, not quadratics, not the ones that have a little square on top of the x. No, just the little one, x to the first power. So let's keep that in mind. Let's keep that information in mind. And now let's graph the same 2 problems that we just did, but now knowing all that without creating a table. In fact, I want us to create a table from the graph. So let's see. Y equals 2x plus 3. Okay, so I have to identify the slope and the y-intercept from the equation. Sure, why not? First, I need to know if this is in the form of y equals mx plus b. And I see that it is. Everything falls into place. So what I'm going to do is I'm going to come right here and I'm going to identify my components. So I say the slope is 2 over 1. Okay? And now the y-intercept is 3, having coordinates of 0, 3. All right. Now, let us talk a little more about the slope. The slope is represented by, people say rise over run. I say the change in y over the change in x. Okay? Never forget that. And there is a formula to find slope, but we're not there yet. Let's take it easy. Let's go step by step. Okay? So like that, we get to regressions faster. All right. So my advice is always start at the y-intercept. Okay, so let me start at 0, 3. 0, 1, 2, 3. All right. And now work your way towards the slope. Well, was the slope a positive number? Yes, it was. So, there are different directions in which the slope can take on. For example, the change in y can go either up or down. Up means positive, down is negative. The change in x, which is sideways, can go right or it can go left. Okay? Right is positive, left is negative. So, there are different combinations that can give you a positive slope or a negative slope. And let's look at them right now before we engage in any further. Look, if a line has this behavior, the slope is going to be negative. If a line has this behavior, the slope is going to be positive. Okay? Explanation for that. Well, how can you get a negative slope if you have change in y over change in x? You can get a negative slope if you have a positive number divided by a negative, or if you have a negative number divided by a positive. Any of these divisions will give you negative, so that will result into this. What does that mean? That means that if you move, okay, if you move, sorry, let me see if I can zoom out so you can see the whole thing. Okay. That means if you move up, positive, and to the left, up to the left, up to the left, up to the left, up to the left, your slope is going to be negative. It also means that if you move down and to the right, down to the right, down to the right, down to the right, your slope is going to be negative. Okay, now how can I get a positive slope? Positive slope can be obtained by either going up and to the right, or going down and to the left, because negative divided by negative is still positive. My God, Bex, I never knew that. You're some type of alien genius. Yeah, right, whatever. Got you. All right. So now that we have cleared, cleared out any doubts that you might have about the slope. Okay, we're not talking about the formula yet. We're just dealing from a graph. Okay, so let's do this. Let's graph. So I started at 0, 3. And then my slope is 2 over 1. And it's positive. So the two instances of positive can be 2 up and 1 to the right. 2 up and 1 to the right. You already know the behavior of this graph. You see that? You already know. So that means that if you go 2 up, 1 to the right, 2 up, 1 to the right, you can also go 2 down and 1 to the left. Remember, down is negative and to the left is also negative. That creates the positive slope. See, 2 down, 1 to the left, 2 down, 1 to the left, 2 down, 1 to the left. Okay? And like that, you already created the line without killing yourself drawing a table of values. But now if you want to work backwards, sure. I will go over here. Look, I will go over here and I say, what is this point? Well, it's negative 1, 2, 3, 4, and negative 1, 2, 3, 4, 5. So I will write negative 4 for x, oops, sorry, and negative 5 for y, negative 3 for x, and negative 3 for y. Look, negative 1, 2, 3, 1, 2, 3. And that is the secret on how to graph a linear equation without creating a table of values. Now, can you do something else? Yes. Grab your calculator, okay? Wow, I'm being very nice. So I'm going to show you. Grab the calculator, turn it on, press y equals, clear everything that is in there. Okay, and now type, okay, 2, and then the x is this button right here, next to the alpha, x plus 3. Now your oh, sorry, let me just turn how do you call that? Reset this calculator. So you press second plus, okay, second and then the plus sign, then you go and you press number 7, which is reset, then all RAM, okay, and then yes, you want to reset? Of course, yes, I do. Okay, so now it's cleared, and now I can just show you again. So 2 and then x plus 3. You graph, and you're gonna have your line right there. It looks exactly the same mine looks like, okay? Now you want to look at the table of values. So second, and then you see where it says graph, it also says table. And that's it. Now look, you can go to negative infinity if you want to on the x, or positive infinity. Now me, I'm not that greedy. Look at negative 4. See negative 4? It's negative 5. And then negative 3, negative 2, negative 1, blah, blah, blah. Alright, now let's use this secret to graph the other equation that we had before, the one that we created a table of values for. So the equation was y equals 1/2 of x minus 2. Alright? So let's identify if this is in slope-intercept form. That's what we call it. Okay? Why? Because this is slope and then intercept form. Remember what I said? This plus could be a plus or a minus for the y-intercept. Alright, let's identify the slope. What do you think is the slope? Okay, very good. So the slope is 1/2. And what is the y-intercept? Negative 2. And what are the coordinates of the y-intercept? 0, negative 2. Cool then. So now, let's graph. The slope is positive, so we already know what the line is going to look like. Okay? Don't ever lose sight of that. And the y-intercept is 0, negative 2. Basically, the y-intercept determines whether the line is going to shift up or shift down. So in this case, 0, negative 2, so 0, negative 2, right here. And then the slope is 1/2. Remember what the slope is. The slope is rise over run. The change in y over the change in x. In other words, up and down over sideways. I think that's a very easy part. Alright, so what is the change in y? 1. And what is the change in x? 2. So it's 1 up, 2 to the right. 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 Or 1 down, 2 to the left. 1 down, 2 to the left. 1 down, 2 to the left. And now, graph. What in the world did I do my ruler? Alright, and of course this would only get you half credit unless you actually label your line. Okay, so we labeled the line. Is there anything else I need to teach you about this before we go into vertical lines and how to find the slope? Oh yes, definitely. What is the slope here? It's 2. What is the slope here? 1/2, or in this case, if we're talking about numbers, 0.5, right? Which slope is greater? 2 or 2/1 or 1/2? 2/1 has a greater value than 1/2. If we look at real values, this is 2 and this is 0.5. So 2 is greater than 0.5. What observation can you make about these two lines and their slope? Correct. The one that had a greater slope had a steeper line. The closer a slope gets to 0, it's like becomes horizontal, horizontal, horizontal. The larger the slope, the closer it gets to infinity, the steeper, 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 to a point that the slope will look like the y-axis. Okay, so yes, the greater the slope, the line is gonna almost become vertical, and if it ever becomes vertical, the slope is not defined. Okay, you cannot. It's like climbing on a road. You cannot climb on a vertical road. But if the slope becomes flat like horizontal, then basically the slope is 0. Like, slope is how much resistance you get when you travel like that on a road. You get tired faster, right? But when you travel on a road that is flat, then I mean, you're not gonna get that much. You're still gonna get tired eventually, but not a lot, right? All right. So now I want to do some special graphs. I want to graph the graph of y equal to a number. I want to graph the following: y equal to 2 and y equal to -3 and y equal to I don't know, 4 for the sake of doing it. For the first one, we are going to try to interpret. We are going to try to convert them into the slope intercept form. Okay, if not, then that's fine. But look, let's say y equals 2. I can write y equals 2 as y equals to 0x plus 2. Is that fine if I do it like that? It is still 0 times x is 0, so it's still y equals 2. But I just rewrite it like that because I want it to look like y equals mx plus b. Okay, that's the only reason. Cool? Alright, so let's identify the slope in here. The slope is 0. Okay, so no slope. So there is no like going up or down. I don't think so. Anyways, no slope. Now let's fill out the table of values based on this equation. So when x is 1, 0 times 1 is, let's do it right here. So this is the equation I'm doing right now. So let me give values: -3, -2, -1, 0, 1, 2, 3. And in here I have 0x plus 2, just for the sake of doing it, remember? Okay, so when x is -3, we have 0 times -3 plus 2, 0 times -2 plus 2, 0 times -1 plus 2, 0 times, anyways, you get the idea. You finish writing the rest, and I'm gonna start actually answering this. 0 times -3, 0, plus 2, 2. 0 times -2, 0, plus 2, 2. Guess what this number is? Yes, you guessed it. So, wait, hold on a second. What's going on? Well, in reality, when we're gonna graph y equal to a number like y equals to 2 or to -3 or to 4, it's a command. Okay, after all these identification, after all these common sense, okay, conceptual understanding that we just got, in reality, it's just saying, listen, whatever you're gonna give for x, y is just gonna be 2. As simple as that. Oh, okay. So then, of course, you got -3, 2, 2, -2, 2, -1, 2, 0, 2, 1, 2, 2, 2, 3, 2. So let's graph them. So -3, 2, -2, -2, 1, 2, 0, 2, 4, 2, 5, 2. Any number that I give for x, y is going to be 2. So what have you noticed? It's a horizontal line. Yo, yeah, but I thought it was going to be like a vertical line because it says y. Don't get fooled by that. Horizontal line. The same concept that applied to y equal 2 applied to y equals -3. So if I was to graph the equation of y equals -3, I will go to, in other words, whatever the values of x are, y is going to be -3. Remember, the slope is 0. There is 0 resistance. We just saw that. Oh, okay. So then, for -3, it will be around here. See that? When x is -3, y is -3. When x is -2, y is -3. When x is -1, y is -3. When x is 1, y is -3. So on and so forth. Do you see that? Okay. Y equal 2. Y equals... Sorry. Y equals -3. And if I was to graph y equals 4, then all I gotta do is go to 4. When y is 4, so 1, 2, 3, 4, and whatever the value of x is, y is always gonna be 4. Yo, Bex, I wish I was your student. I wish I was my student. Know how many things I would teach me? Shh, I'm nice. So this is how you graph horizontal lines, and they are of the form of y equals 0x plus a constant, or y equals to a number, however you want to look at it. And the next I want to show you is the equations of x equal to a number. Okay, so I want to graph x equal to x equal -3 again, and x equal 4. I'm just gonna mess around with the same numbers I used before. Alright, so in this case, the tables turn. I am pretty sure that you already know what's gonna happen, what kind of graphs these are gonna be based on your observation. But let's see now. So what is this saying? That x is 2. So whatever value of y I give, x is gonna be. The roles have changed, my friends, because this is a command. Okay, there is no, in this case, there is no y equals mx plus b that I can write, but since I already explained to you about the command, okay, whatever x is, y is gonna be 2. So same thing here. So if y is -3, y is -2, y is -1, 0, 1, 2, 3, whatever y is, it says that x should be 2. Alright, let's put this to the test. 2, -3, 2, -2, 2, -1, 2, 2, 2, 2, right? So let's see now. 2, and let me change the color. And do I have red around here? Do I have red? Oh, I don't have red. I did have red. Where's the red? Don't play with me. I don't think so. No red. You know what? No, don't play with me. Where's the dog? Oh my God! Please don't move. Dun, 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 dun. Okay, found it. All right, so let's graph it. Let's see that. Negative 2, comma negative 3. 1, 2, 3. Negative 2, comma negative 3. Negative 2, comma 1, 2, 3. Negative 2, comma negative 2. Negative 2, comma negative 1. Negative 2, comma 0. Negative 2, comma 1. Negative 2, comma 2. Negative 2, comma 3. Negative 2, comma 4. Do you get the point? Do you get the idea? Exactly. The equation of x equal to a number, okay, it's a vertical line. So now that you understand that concept, okay, again, the equation of x, yes, I know what you're thinking about, x. So x equal to a number like 2, it's a horizontal line that goes through, okay, not horizontal line, a vertical line parallel to the y-axis that goes through all the points where x is 2. Becker, just tell the students that you messed up, okay? Or just pretend that you did it on purpose, because you actually graphed x equal negative 2. And I messed up, right? Why? Yes, I messed up, and I'm gonna tell you right now that I did not graph x equal 2. I graph x equal to negative 2. So I'm gonna fix it right there. X equal negative 2. I'm so sorry I created all this, but it still works. You see that? All the points where x is negative 2. Let's graph x equals negative 3. So that means that I'm gonna move on to negative 3 right here. And now this one I'm gonna have to do in blue. Negative 3. I'm doing this correct. Okay, that is the equation of x equal negative 3. Now let us graph the equation of x equal 4. Well, 1, 2, 3, 4, so it will be around here. You see that? Right here. So x equal 4. 1, 2, 3, 4. This time, I did all of them correctly. I apologize. Now, the concept still applies. X equals negative 2. That means that for whatever values of y, x is always going to be negative 2, based on what I explained over here. Alrighty? Good job. Alright, see you. Alright then. So let me see if I can do this. Let me turn one of the lights on. Hopefully it won't damage the view. It's better. Hi, yeah, that's me. Yeah, I'm a little tired. It's freaking Saturday. Alright, I don't have any paper with me, so what I'm going to do is I'm going to create the equations and we're going to solve for y. The first one. Oh, wait. Do me a favor. Write down these rules for solving for y. First of all, get rid of the x term by using the additive inverse. You know, you have 2x, you do negative 2x. You got negative 2x, you do positive 2x. Alright. The second thing I want to tell you is, once again, I'm going to write the same thing here. So, get rid of the constant. Okay, that's it. I lost you, right? Yeah, I knew I was going to lose you. The constant is nothing more than a number, regular number, like 8, like 7, like 9, like all that. All right? That's what a constant is. Just a number without a variable. A number without a variable is a constant. Got it? Okay then. Last but not least is use the multiplicative inverse of is multiplying the y. Okay? These are the three essential rules. If you can follow them, you could solve for y anything. You understand what I'm saying? So copy it. Alright, so you pause it, you copy. Let's continue with this. Hey, yo! Man, I have no jokes today. I'm really tired. And it's OD snowing out there. Could you believe that? It's amazing. I don't know if I'm a workaholic or I'm a whatever. Alright, so let's create our own equation for y. 2y minus 2x equals 3. Alright. So what is your goal? Your goal is to have this at the end. Y equals. You understand what I'm saying? Alright then. That is your goal. So let's see if we can do this. Let's follow Beker's rules. Let's see what happens. The first one says, get rid of the x term by using the additive inverse. Well, what is the additive inverse? I need to put everything except for this on the other side. So the additive inverse of negative 2x is, right? Good. Bring down the 2y. Cancel this out. Bring down the equal sign. And my favorite question to you is, what is 3 plus 2x? 5x, Mr. Beker? No. Negative 1x, Mr. Beker? No. And then of course there's going to be the smart people going like, you can't do that. I'm sorry. That's impossible. Why? Because like an hour ago when you started the video, you said that they were not like terms because you couldn't combine them because this doesn't have an x. That's right. That's right. So 3 plus 2x is nothing more than bring down the 2x, and then this is positive, plus 3. Or 3 plus 2x. You could write it either way. But for me, always make sure that it is the x goes first, okay? Just make sure that the x goes first. Alright then. So I got rid of the x by using the additive inverse. Then it says, get rid of the constant. There is no constant here, okay? Just like the additive inverse, there is no constant number. Alright, so let's skip it then, as simple as that. We're not gonna get stuck right here. So, use the multiplicative inverse of the term that is multiplying the y. Alright. What is the multiplicative inverse of 2? Alright. 2y times 1 is 2y over. Now here, 2x, remember, now you are using the distributive property. Ah, you like that, right? Well, 2x times 1 is 2x over 2 plus 3 times 1 is 3 over 2. But why do that? Why didn't you just divide by 2? Come on, why are you making our lives miserable? You're gonna appreciate this, okay? You're gonna thank me later when you see the OD fraction that you're gonna be faced with. You understand what I'm saying? Alright. So, my goal here is for you to understand that you must use the multiplicative inverse before you divide. Once you become acquainted with that, used to it, then you can start dividing by 2 and nobody will mind, but at least you know what you are doing. 2 divided by 2, nothing, is 1, okay? Not 0, 1. And x, okay? Plus, well, 3 over 2.